Polyester-coated PVC fabric is the most used material. We are dealing with other materials which are more sophisticated. But for sure, PVC-coated is the most common because it's recognized as one of the most highly performant material compared to materials compared to its cost, which is quite low. What we do as in our company is to tailor PVC coated fabric, and we are exactly what tailor means. We just cut and model PVC and create the so-called lightweight structures. A lightweight structure is a structure which is able to bear very big loads compared to its self-weight. The evolution of PVC, it did really perform better with surface treatments at the beginning on top coats to protect the PVC underneath. I mean the polyester fabric, which is, I think you all know that it's sensible to UV, to aging, to also changing colors. So those top coats has been really implemented at the beginning with PVDF plus acrylic, then Textile, then concentrated PVDF to improve self-cleaning, whiteness, and of course the durability. Another big issue is the fire behavior of this material, as you need to apply them for public uses, and they need to be safe. During the years, we had a lot of, every single state has his own laws. Now we have an harmonized standard, finally, because we were all looking for that, because you needed so many certificates, and all the PVC suppliers needed to have as many certificates as states where they were going, so it was really an issue. Now this harmonized standard is really helpful, and meanwhile it has also been improved in the fire behavior with ingredients that are really very they're really helpful. We have been talking a lot today about sustainability, about what I will go there. I mean, after all, after the next slides, I will show you a little bit more about what we think could be sustainable for PVC. Even more about energy efficiency. Another application which is now very common in textile architecture is the use of mesh fabrics for facades. Those mesh fabrics help to renew the aesthetical aspect of a building in a quite easy and quick way. And also, why not, there's another implementation besides aesthetic, which is the fact that the mesh fabric can be ventilated. I mean, leaves the air pass through, so you have a ventilation in the wall, and also a protection from the solar radiation, which is something that helps a lot in the climate control, energy saving inside the building, and this kind of application is becoming very popular now. PVC now is becoming more and more competitive, and what it has been thought at the beginning to be an application just for small buildings or with temporary use, it's now becoming used even for big stadia. For example, you can see the last one in the picture, and because it's improving a lot in durability and also in tensile strength and resistance, because you need that to build up a textile structure. A lot of implementation are still on because the market is asking for lighter and more translucent material, because they have understood also the importance of having natural light inside the structure, which reduces a lot the cost, the energy that you need to keep everything lighten up, and also improves the internal comfort of the end users. What I was saying also for plans for the future, we have been talking about recycling. So the problem for example, we are cooperating with Texyloop, with Ferrari. I know that Vienna Plus is together too, in the Ferrara plant in Italy. The problem is that it's still too high costly compared to what you get back. So we really strongly believe that this is a good solution, but because you have to transport the material, you have to reuse it, you need energy to basically divide and take off the grains and those things, and it's really still a little bit too high, and to just get to the waste, it costs less, so it's not really working that much. But what I think it's the most challenging thing is what we can do for recycling, for what materials that we have, such as, for example, the first project on the left, it's the realization of a yurta tent, and it's been given to Africa. It's like a surgery center at the moment, and they use skis as poles, and they cover it with this PVC. And, for example, skis, as far as I know, as I've been told, are one of the materials which are really not recycled at the moment. So this could be something that's helpful. The other one is from the Polytechnic of Milano. They got a patent in this. It's a flexible wall and could be used for maybe in the event of earthquakes. You could just, it's very easy, foldable, light. You just use the materials that are coming from the disaster itself to build up walls and temporary or emergency buildings in which you could stay there, which I think is very, very nice. The other two are more effective products at the moment, which this is a prototype. They have been for the temporary bridge. It's something that can be. It has been calculated that you use just 2 lorries to carry the necessary equipment to build a 38-span bridge, and it takes 48 hours to build it up. So this could be very useful in case of flows or whatever other emergency application. Well, the other one is just the use of textile to gather the energy production. So I think I try to be very quick, and I hope that I just give you some ideas of what could be done in the future with PVC, which potentially is very, very helpful.